Okay, we're going to look at a third method of solving linear systems, linear equations. And for this one, we're going to use this to give you an idea what we're talking about here. All right, so here's Mr. Claudio's typical order from his lunch at McDonald's. I bet you had no idea he could pound it away like this, but be amazed that little guy can actually eat. It's quite impressive, actually. Now, notice how things are actually not just randomly placed all over the place. Here we have some fancy chickenish type burgers here. We've got some egg McMuffins over here. There's the quarter pounders. There's a few things going on here, but things are sort of clustered together a little bit. And that's the exact same idea we want to use with our third method of solving linear systems. We're going to try and group similar things together. Okay, and that way, when suppose you want to focus on one thing and you just want to eat chicken burgers, you know exactly which tray to go to get rid of them. If you want just to make muffins, you know exactly where to go just to get rid of them. Or the quarter pounders, whatever you want. You can focus in on one little part and get rid of it. But you sort of have to have things grouped together in similar places to do that. If things are just randomly placed all over the place, you'd have to look all over just to find just those specific quarter pounders. It would be a lot more difficult to do. Okay, now to do this and actually work with this, it's actually going to be very similar to something else you guys did way back when. So for example, if you're going to add 2300 plus 150. Now, when you first started learning how to add and subtract stuff like this way back when in elementary school, what you would do is you would do something like this, and you do plus, and you'd line up the different things. You'd line up the ones, you'd line up the tens, you'd line up the hundreds and the thousands. Of course, there's nothing here, and then you would add it up. You would not do it like this. Okay, that does not work. You have to have the proper pieces lined up so they match up so you can actually put them together, and putting them on top of each other like that is a great way to visualize that they represent the same type of value, and you can actually put them together. And the same thing applies for what you guys are going to be doing for linear systems, where instead of using just plain numbers, we can use the expressions. We can actually use the x's and y's and things, because not only can you add and subtract numbers like in questions like this, but you can add and subtract letters as well. And you guys have done that before with polynomials and stuff like that, but that's where that's going to kick in. So these are the basic ideas of how we are going to look at a new way to solve linear systems. Okay, so let's get rid of all this stuff here. Delete. All right. So this method is what is called elimination. Okay. So there's different names, but this is a really common one is elimination. And let's sort of just show you how this works. Suppose we have two expressions, 2x plus y is equal to 6, and we have 3x take away y is equal to -1. Now I want to solve this. So I could graph it, I could use the substitution, but I want to show how to use elimination. And elimination is actually really simple a lot of the time. It usually works really well. And I'm going to do the exact same thing as when we had the 2300 plus 150. I'm literally going to do the exact same thing with the linear expressions. Now notice that these guys are all lined up. The x's are lined up, the y's are lined up, just same way the ones, tens, hundreds are lined up. I lined up the variables and the type of variables on purpose. Okay. Now in the previous one, the substitution, I often like to do those side by side. These ones you kind of got to do on top of each other, the same way you did the old-fashioned adding, subtracting. And I'm literally going to do the same thing with these expressions right here. Okay. So you want to write them typically on top of each other. But then what you're going to do is you are going to, and this is sort of like step one, you look for a variable with the exact same coefficient. So I look at my x's. Well, one x has got a 2, the other x has got a 3. They're not the same. Okay. Now, if I look at my y's, the coefficient for my y here is 1, and here it's -1. Well, that's kind of the same. So you want to look for the same coefficient. Now, the only thing is it may be opposite sign. Okay, so maybe plus 1. That's fine. But my y's both have a 1 in front of them. One's a plus, one's a minus, but they both have 1s in front of them. This is what I'm going to target right there. Now, what I'm going to do is I want to put those two expressions together. So if I would take these two expressions and I would add them the same way you add these, if I take that positive y and I add a negative y, it will cancel out and they will eliminate, and that's the whole idea behind this. So let's add the expressions together the same way we add this type of stuff. 2x plus 3x would give me 5x. Plus y minus y gives me 0y. Now, of course, you don't have to write that, but whatever. And the 6 plus negative 1, that gives me 5. All right. So, of course, this is just gone. So I got 5x is equal to 5, which means, of course, x is equal to 1. And that's how elimination works. So the first thing you got to do is you have to look for a variable with the same coefficient. And then what you have to do is you have to add or subtract to try and actually eliminate that variable, okay, the one that you found over here. So in this case, I added the two expressions, and if I add a positive negative, of course, they cancel out. And then I'm able to solve for, you can actually solve for the actual remaining variable, okay? Well, of course, now that I have my x value, I also want to solve my y value. So this is similar to what we've done before, okay? You have to substitute back in order to solve for the other variable. So you can pick whatever expression you want. It doesn't make any difference. I'll use the first one here. I'll use the 2x plus y equals 6. So I've got 2. I know my x value is 1 plus y is equal to 6. So 2 plus y is equal to 6. So y would be equal to 4. So if I would put this all together, I've got my x value here, I've got my y value here. The answer to the question, or the solution to the system, would be 1, 4. So if you would graph those two lines, they would intersect at 1, 4. Okay, so this is the basic idea behind elimination. All right, so let's do some more and practice with this a little bit. Okay, so I clean things up and I move the little steps over there to help myself out. And let's try another question. So let's try negative 6x take away 5y is equal to 5. And I've got 6x take away 7y is equal to 7. All right, so I want to look for a variable with the same coefficient. So the one that matches up would be these guys right here with the two 6's. All right. So if I wanted to eliminate them, if I want to get rid of them, I would have to add them together. So I'm going to add that system together. All right, so if I add them together, negative 6x plus 6x, of course, cancels. I'm not even going to bother writing it. I've got negative 5y plus negative 7y is going to give me negative 12y. And 5 plus 7, of course, is 12. And you can see that y would then be equal to negative 1. Okay, I'll then substitute that back into my original question, or one of my original questions, and it doesn't really matter which one you use. I'll use the second one here. So 6x take away 7, and I know my y value is negative 1, is equal to 7. So 6x, that of course will give me plus 7 is equal to 7. So I will subtract 7 from both sides. So I subtract 7 from both sides. I got 6x is equal to 0. And then obviously x is going to be equal to 0. So my solution for this one, my x coordinate is 0. So that, there's an intercept involved right here. So we got y equals 1 or negative 1. So my answer would be 0, negative 1 would be the answer for the system. Okay. All right. Well, let's try another one. Let's get rid of this. And let's try another question. Okay, so let's try, let's try 10x plus 2y is equal to 16. And we've got 7x plus 2y is equal to 10. All right, let's put these ones together and solve these ones. Okay, well, I'm going to first of all look for same coefficient. Well, that would be this one right there. So I'm going to use that one. So in order to solve this one, I've got plus 2y and plus 2y. In order to cancel those out, I'm not going to add them together, because if I add them, I'll get 4y. I don't want 4y, I want 0y. So this time I'm actually going to have to subtract instead. But the same idea will apply. So I'll subtract everything. So 10x take away 7x leaves me with 3x. 2y take away 2y is 0y. Good. Well, I should actually put that where it belongs. Over here. And so 16 take away 10 gives me 6. All right, so 3x is equal to 6. So divide by 3 on both sides, and x is going to be equal to 2. All right, so now I'm going to put that back into one of the original expressions. I'll use the top one this time. So 10 times 2 plus 2y is equal to 16. So that's 20, of course. So I'll subtract 20 from both sides. So 2y is going to be equal to negative 4, and then y is then going to be equal to negative 2. So the answer for this one would be 2 and negative 2. There's my 2, and there's my negative 2. Of course, I can throw them back in here and see if it works. If I put 2 in here, that would give me 20. I put negative 2 in here, that would be negative 4, and 20 plus negative 4 would be 16, so it looks all good. Okay, all right, let's try one more. All right, so let's try x take away 4y is equal to negative 5, and negative x plus 4y is equal to 3. All right, let's see if we can put these ones together. All right, so a thing they have in common, well, there's 2 in common. You know, the x's have 1's in front, they have in common. The 4's have, well, the y's have 4's, they're in common. Okay, well, let's see what we can do here. Let's just try adding them together and seeing what happens. Well, if we add them together, x plus a negative x is 0x. Negative 4y plus 4y is 0y. And negative 5 plus 3 is negative 2. Well, those are just zeros. 0 is equal to negative 2. Well, that doesn't seem to make any sense. Well, that's because this system has no solution. Okay, so these two guys don't meet. If these guys were graphed, if you graph these two functions, they never, ever, ever actually crisscross. These guys are parallel to each other, and that's why there's no solution. Okay, that also happens sometimes, and these guys are parallel. If instead you can have something else where everything cancels off, sometimes you had like 0, 0, 0, like everything was gone, all you had was zeros, then you have infinite solutions, and the two lines are actually sitting right on top of each other. So we looked at those special cases actually when we looked at the other methods as well. Well, it can come up here as well. If you have something that's equal to something else that just cannot be equal, no solution, will never actually meet. And if everything canceled, all you have is zeros everywhere, that means there's infinite solutions and they're right on top of each other. Okay, so there's basic elimination, and we'll do some more practice in the next video.